Live vaccines, vaccine itself has live organisms. It will enter in our body and multiply in our body and produce immune response. So this one has immunogenicity, infectivity, but there is no pathogenicity. That means it won't produce the disease. It won't have virulence. That means it won't produce the severe disease. So example, we have BCG, OPV, rotaviral vaccine, measles, rubella, yellow fever vaccine, varicella zoster. So two vaccines at the same time we can give if it is of different site. For example, BCG is intradermal and oral polio is of which route? Oral route. We can give together. If we are not giving together, there should be minimum of 3 weeks interval. Suppose we have given BCG vaccine today and we forgot to give oral polio vaccine or something, and after 1 week we should not give OPV. There should be a gap of 3 weeks. After 3 weeks only we can give that patient OPV vaccine. And comes killed vaccine or attenuated vaccine. So organisms is already killed, so it is inoculated into our body to produce immunity. We have inactivated polio vaccine, pertussis vaccine, Japanese encephalitis vaccine, and rabies vaccine. So here to inactivate the microorganism, they use heat or formalin. So we have subunit vaccine. Subunit vaccine, part of virus or bacteria, is used as a vaccine to produce immunity. So we have toxoids. Toxoids are toxins. Diphtheria toxoid we have, tetanus toxoid we have. Some protein of the virus. So we have influenza vaccine and malaria vaccine is also of protein vaccine. Recombinant protein vaccine. So difference is here from the infectious agent. Suppose this is the infectious agent, we are going to produce the protein. This will be used as a vaccine. But here recombinant, from an infectious agent, this gene is inoculated into another organism. From here this will produce protein, so we are going to use this protein as a vaccine. Then polysaccharide vaccine, we have some of the organisms are having outer covering of polysaccharide layer, mostly of capsulated organism. We are going to give this meningococcal vaccine, Haemophilus influenza B vaccine. Conjugated vaccine, next one, that is made up of protein and polysaccharide, carbohydrate. Example, pneumococcal vaccine. Now combined vaccine, we know, as we all know, pentavalent vaccine. We have diphtheria tetanus, DPT, diphtheria pertussis tetanus, DPT plus typhoid, we have DPT plus polio, we have MMR vaccine, measles, mumps, rubella, we have hepatitis A and B together, we have hepatitis A plus typhoid we have. Now components of vaccine. Vaccines are not only made up of infectious agent or toxoids. Their components of vaccines are adjuvants, antibiotics, stabilizer, and preservative. Adjuvants is used to enhance the degree or duration of the vaccine. We have aluminium salt, aluminium hydroxide, sulfate, and phosphate. Antibiotics we used in vaccine is neomycin to prevent the secondary bacterial growth. Stabilizers, we have to control the pH of the vaccine, and stabilizer also prevent the othering of the vaccine in the wall of the ampules. And for example, stabilizers, we have serum albumin as stabilizer, lactulose, sodium, potassium salt, and gelatin. Preservatives, this is to inactivate killed vaccine or detoxify toxoids, and also prevents the secondary growth of the fungus or bacteria. Example, we have formaldehyde or thiomersal. Now future prospects. These are the new variety of vaccines we have. recombinant viral vector vaccine. Suppose this is a virus agent going to produce certain disease. From here we are going to take out the gene and we are going to inoculate gene in another virus, and we'll be giving this virus as a vaccine. But this is a live non-replicating virus. For example, Sputnik COVID-2 vaccine they are using adenovirus. So from the COVID-19, they have removed the gene and inoculated into the adenovirus. Used this adenovirus for the vaccine preparation. And we have recombinant protein virus vaccine. So as we discussed earlier, so one organism, they'll inoculate the gene into another organism. That organism going to produce the protein. So this protein will be used as a vaccine. Example, hepatitis B vaccine. Now subviral component. So some part of the organism will be injected as a vaccine. Example, RTS malaria vaccine. Now synthetic peptide. Using chemicals, they are going to make the antigen. So example, we have Neovax, that is for breast cancer. GP100, that is melanoma peptide vaccine. We have edible vaccine. So some of the genes are inoculated into the plant's DNA. So that will produce the protein. So example, some potato or corn or tomato. So they'll be inoculating the gene into these plants. And in future we are going to eat that fruit containing the protein. This protein will induce immunogenicity. Example, they have developed hepatitis B surface antigen in these plants. Hand foot mouth disease core antigen also produced. Naked DNA. So here only the part of the DNA will be inoculated into or injected into human as a vaccine. Example, Psychov-D vaccine is of naked DNA vaccine. Local vaccine at the portal of entry of the organism. Suppose for influenza, portal of entry is of nasal cavity. So we are going to use nasal spray vaccine for influenza. Polio, portal of entry is oral. So OPV vaccine is given as oral route. The next topic is of cold chain equipments. Cold chain equipments we have for storage and we also have for transport. Electric equipments we have, and non-electric equipments we have, solar equipment we have. In electric we have walk-in freezer, and the word says freezer. This is a prefabricated polyurethane foam insulated cold room. By generator we have temperature monitor and alarm system also it has. The temperature maintained in the freezer is always -15 to -25 degrees Celsius. So we are going to keep OPV vaccine and ice packs in the walk-in freezer. So at national level, regional level, state level, they are using the walk-in freezer. We have walk-in cooler. Same polyurethane foam insulated cold room. It also has 2 units and on generator, temperature monitor, alarm system. Here temperature maintained is +2 to +8 degrees Celsius. It's a cooler, not a freezer. So here we are going to keep universal immunization program vaccines, all the vaccines. So again same thing, national level, state and regional level, we are going to use this walk-in cooler. Next we have deep freezer. Again the word contains freezer. So the temperature maintained is -15 to -25 degrees Celsius. Mechanism used here is a vapor decompressor system, as like our refrigerator with 220 volt AC. At district level we are using the deep freezer. Below district level we are not going to use it. OPV and ice packs are kept at this deep freezer. At a time either one is kept. So hold over time is 2.5 hours at 43 degrees Celsius. Holdover time is the time taken by the equipment to raise the cabinet temperature. If we kept at 43 degrees Celsius, it will take 2.5 hours to increase the temperature from the minus 15 to higher range. We have ILR, ice lined refrigerator, same as deep freezer vapor decompressor system, but with that in the wall they have ice pack lining, so temperature is maintained much higher than the deep freezer. So holdover time here is minimum of 20 hours. For deep freezer is 2.5 hours. Why? Because of this ice lining. So at district and sub-district level we are going to use it, and temperature maintained is +2 to +8 degrees Celsius. And all universal immunization programs vaccines are kept at this ice line refrigerators. So it has two compartments. Heat sensitive vaccines are kept at the bottom, and freeze sensitive vaccines are kept at the top portion. So heat sensitive example, oral polio vaccine, measles, BCG vaccine are kept at bottom. So upper all toxoids like TT, pentavalent, those vaccines are hepatitis B are kept at the upper part. There should be an alcohol thermometer inside. All the, even in the deep freezer as well, thermometer is kept inside as well. On the outside also there is a thermometer attached with the machine. Small size ILR is also there, large size ILR is also there. Next one is domestic refrigerator, same vapor decompressor system, maintains +2 to +8 degrees Celsius. So private clinics and nursing homes are using these. Holdover time is only 4 hours. Next one is non-electrical. We have cold box. There is no connection with electricity. This lined by ice packs. So it will hold the temperature for more time like ILR. So ILR we studied that minimum of 20 hours it will hold. Here it is a small size, it will hold for 48 hours. If it is a large size of 25, large size means 25 liter, it will hold for 96 hours. So usually we use this for the transport of the vaccine. So when electricity failure happens, that time ILR we won't be able to keep the vaccine more than 20 hours. That time, for a particular time period, we will be transporting the vaccine to a cold box, and then they can hold up to 48 hours. So we can plan where to ship the vaccine, or else if electricity come back, we can again transport back into ILR itself. And next one is vaccine carrier. This is also mainly used for the transport of the vaccine. It has 4 ice packs, 1, 2, 3 and 4. So we'll be keeping the vaccines of 16 to 20 while it can hold in the polythene bag. We'll be keeping the vaccines inside, so it can hold for 36 hours. Day carrier, usually to the immunization session site, ANM will be carrying this day carrier. So one box has 2 ice packs, and then in the polythene bag 6 to 8 vials of vaccine that can hold over time is very few hours. Now, ice packs, the vaccine session site will be having ice pack. So we'll be removing one ice pack from here, and we'll be keeping the ice pack. So there are 2 holes in the ice pack. So heat sensitive and light sensitive vaccine, that is BCG and MMR, amber color bottle it will be there. So we are going to keep those 2 vaccines in the holes which is there in the ice pack. Other heat sensitive vaccines like OPV, JE and rotaviral vaccine, we are going to keep it over the ice pack, and other heat resistant vaccine we can keep it in the tables only. Ice pack, we should always fill the water this much up to this mark, because after freezing this water will expand. Before keeping this ice pack in the carrier, we should do conditioning of the ice pack. For that, we are going to keep the ice pack outside for some time. We are going to let melt the ice little bit so that it won't damage the free sensitive vaccines like DPT, hepatitis B and all. Next, we have solar equipments. So solar refrigerator battery drive we have, solar refrigerator direct drive we have. So this battery drive polyurethane foam insulated. One will keep the temperature of +2 to +8 degrees Celsius. One other side up to -7 degrees Celsius. So they use solar energy to charge the battery. So other one, solar refrigerator direct drive. They use solar energy to freeze the water containers inside that refrigerator. Now for the transport, we can use refrigerated vaccine vans are there. We have insulated vaccine vans. We have cold box as we studied earlier. We have vaccine carrier. So we are at the end of our lecture. We have studied about vaccines. So types of vaccines, we have live vaccine and killed vaccine, also called attenuated vaccine, and subunit vaccine we have, and then combined vaccines. And then we have the components of vaccines like adjuvants we have, stabilizers we have, antibiotics we have preservatives. Future aspects of vaccines we studied, and cold chain equipments we studied. So hope all understood the lecture, and thank you for listening.